Okay, in continuation with our second module, we are moving to the next interesting topic, a solar thermal conversion. A solar thermal conversion. So far, we discussed what is meant by solar radiations, what are the solar geometries, simple definitions, equations, how to calculate some of the datas like hour, angle, declination. Okay, everything we discussed. So now we are going to discuss the same solar radiation, but how we are going to convert or how we are going to collect and how we are going to storage the solar radiation or solar rays or solar heat. Okay, so this is a very interesting topic. Here, how we going to collect the rays? First thing, second thing, how we convert and how we stored. So the thing we discussed in your second bit of second module. Okay. So first we will discuss solar collectors, different types of collectors, and how we are going to collect and what are its construction. Okay, what are the important components? Everything we are going to discuss. Later we are going to discuss what is meant by solar storage, how we are going to store the solar energy. That we will discuss later. First we are concentrating on solar collectors. So both comes under in the solar thermal conversions. Okay. So this solar collectors are a storage, maybe collectors are a storage. Both are a devices. Okay, both are devices for collecting and store the solar energy. So solar collectors are storages are the devices which are used to collect and store the solar energy or solar radiations and then transfer this energy to the any media like fluid or air, anything, any media uh, passing in contact with that and utilize this solar energy for required furthermore applications. Okay, so these solar collectors or storages are the devices which are used to collect and store. Okay, these are the devices which are used to collect and store. Then these are they are transfer the solar energy from the solar radiation to the given fluid. It may be liquid or it may be gaseous, whatever it may be, like given media, and it transfers. Then once the transfer is over, then it will taken to the next step, means either it will convert for as an heat energy or electric energy for furthermore utilization of this solar energy. Okay, if you want you can directly go for the any applications. If it is excess you can go for the storage. Okay, and come to the solar collectors. Only we were concentrating on solar collectors. So there are two important types of solar collectors. There are two important types of solar collectors. The first one is a non-concentrating. The first type is a non-concentrating or a flat plate collector. It is called as a flat plate collector. Okay, there are two important solar collectors. Solar storage we will discuss later. Only concentrate solar collectors, and these solar collectors are the devices which are used to collect the solar radiations and transfer that energy to the fluid passing over it. Okay, and there are two important type of solar collectors. The first one is a non-concentrating or a flat plate collectors, and second one is concentrating or focusing. It may be focusing or concentrating type of solar collectors. The first one, non-concentrating or a flat plate type of solar collectors. In this type, okay, so in this type, the collector area, okay, when compared to the concentrating, okay, so in the collector non-concentrating type of or a flat plate collectors, okay, uh, so the solar energy collectors and these it may be non-concentrating or concentrating. So these devices always associated with the observer. Okay, we need a one observer, means the solar energy from the sun, it emits the solar energy. Okay, and solar energy reaches the earth. But we need a one observer. Observer means the collector, okay, the observer. And this is an essential component. This observer is an essential component for both concentrating type and non-concentrating type. And this solar radiation energy, it's a more useful form, means this absorbs and it will convert for the useful form. It may be heat energy or it may be electric energy. So these are the two type, and these two type have a one essential component called observer. Okay, so this observer will absorbs the energy and this will converts that one form to another form. Okay, and if you go with the first one, a non-concentrating type, the collector area means the observer area or a collector area. So the collector area and the collector area and the area intercept the solar radiation is same as observer area. Means in the flat plate collector, whatever the collector area is equal to the observer area. If more the collector area, it will absorb more solar radiation. Okay, and this absorbing the radiation. But when compared to the second one, concentrating one, okay, here the area intercepting the solar radiation is greater, sometimes 100 times or 50 or 100 times than the observer area. Means in the concentrating type, we are using only small observer area, but the collector area is more. But in non-concentrating type, whatever the collector area which is equal to the observer area, because it is not concentrating, it is just a flat plate collector. Clear? But concentrating type, okay, the observer capacity is more because it is concentrating all the whatever the radiations falling on that observer area, it is concentrating through a one point, through a point or through a line, so that concentrating all the whatever the rays falling, it is concentrating only a one point or one line, so that the efficiency is always higher. The efficiency of concentrating type is always higher than the non-concentrating type. But in case of first one, maximum we can achieve 100 degree centigrade in case of non-concentrating, because it is a flat plate. So maximum we can achieve 100 degree centigrade. But in the concentrating type, we can achieve easily 350 degree centigrade. So the efficiency is always better, as well as we can achieve more higher temperature when compared to the concentrating type. So by means of this concentrating collectors, much higher temperatures can be obtained, and with a non-concentrating type. Yes, obviously. The concentrating collectors may be used to generate a medium pressure stream. Always this concentrating type used to generate a medium pressure stream, and thus may many different arrangements or mirrors or a lens concentrating this sunrays on the boiler, and this type shows that better efficiency than the flat plate collector, and always it is better efficiency when compared to the non-concentrating type. So in the both type, the observer is the a common essential component. Okay. So next, move on to the physical principles of conversion of solar radiation. A physical principle or a principle of solar energy conversion to heat. How we are going to convert that solar radiation or solar energy into heat? Either we can convert that solar radiation into heat or whatever the useful form, that is electric energy. Either we can convert heat or electric energy, but generally first we are going to convert heat. Okay, so this is a common a phenomena called a greenhouse effect, the fundamental process. So now in a general use for heat conversion, which is called as a greenhouse effect. You already knew that what is meant by greenhouse effect. You already studied in your schooling days or in PU, okay? So what is meant by greenhouse effect? So greenhouse effect means increasing the atmospheric temperature or warming the atmospheric temperature. The general definition, okay? I'm going to say that the general definition is greenhouse means it's a increasing the atmospheric temperature. It is called as a greenhouse effect, okay? The same concept we are using here just to convert the solar radiation into heat energy. The name come from it's the first use of greenhouse in which it is possible to grow vegetable plants or a plants or a vegetable plants. Okay, so in a cold climate through the better utilization of available sunlight. So most of the, we know that most of the plants will absorb the sun energy and they will convert that sun energy into useful form of energy through the photosynthesis process. Okay, they will generate the food. Okay, then that food is carbohydrates and the plants and the trees are rich in the carbohydrates and they can use for other the heat conversion process. Okay, so here, so the most of the energy we receive from the sun comes in the form of light. We already know that the most of the energy. That's why the sun solar energy is always effective in the daytime rather than in the night time. Night time there is no sun, there is no light, so that we won't get any energy from the sun. So the most of energy what we receive from the sun is come from the light, the shorter radiations. The light we already know that it is a shorter wavelength. It's a shorter wavelength. And not all of the visible to the human eyes. We already know that in the light spectrum, shorter wavelength, longer wavelength, visible light. Okay, so human can visible light, okay, ordinary light, and some short wavelengths, some long wavelengths. And when this radiation strikes a solid or a liquid, and it absorbed and transformed into heat energy. The solar rays transmit the shorter wavelength or longer wavelength, and this shorter wavelength reaches the earth, and these radiations will strike the solid body. Okay, solid particles are liquid particles, water particles, solid particles are gaseous particles, and these will strikes and the particles will absorb and transfer that into heat energy. The material become when warm, and this stores the heat and conduct it into the surrounding materials, that is what air, water or any other particles, and re-radiate it into the other materials to the lower temperature. This re-radiation is a longer wave radiation. Okay, so whatever the solar energy we receive from the sun, it will strikes the particles and those particles will absorb the energy because of the radiations and they will get heated, and once they will get heated it will start emitting the heat or start dissipating the heat to the surrounding particles. It will first stores with their limit, then if it is excess it will start dissipating to the surroundings. Okay, and it will start re-emit or re-radiate the energy, and they will become the longer wave radiations. And this is what you just observe in the figure. Okay, so in the figure you just observe, so this green, what is meant by greenhouse effect? Okay, so greenhouse effect is the vital to the existence of life. So with a greenhouse effect there is an activities of human beings or living things. If there is no greenhouse effect there is no living things. Okay, so then what is meant by greenhouse effect? So greenhouse effect means, or greenhouse means, greenhouse effect is different. Greenhouse effect means it will increase the temperature of the atmosphere or global temperature. That is a greenhouse effect. What is meant by greenhouse? Only greenhouse. So greenhouse means it's a glass building. If you consider it is a transparent building used to collect heat to grow the plants in a controlled temperature. Okay, so greenhouse means it's a glass building. So it is constructed by purely a glass just to collect the heat, and that heat will helps to grow the plants. That is what greenhouse. Okay, the general greenhouse effect means the gases in the atmosphere. This is what artificial greenhouse means, man-made. So man will construct the some area with the help of glass, and within the that glass or that building, they start growing the plants. Okay, so this process is called as a greenhouse. You just observe in the some agricultural land, they covered with a glass or covered with a, some green color, and they will start growing the plants. Okay, that is what greenhouse. But now, what is meant by natural greenhouse effect? The natural greenhouse effect means there is a means that atmosphere having so many gases like just H2O, CO2, CH4, okay, O2, CO. There are n number of gases, and those gases in the atmosphere trap heat close to the surface of the earth. They will trap the heat. Trap means it will they will absorb the heat. They will absorb the heat and will trap the heat. They won't allow heat to dissipate. They will trap the heat. And because of this process, it will increase the temperature of the atmosphere, and it will start slowly warms the planet. So our planet is warmer. Okay, it is not colder, it is a warmer. So if the temperature is warmer, then there is an living activities will taking place. If it is a cold, there is an almost nil in the activities. You just observe in the north and south pole. So north and south pole, so human beings or any most of the animals, they cannot survive in the north and south pole because the temperature is very less. Okay, but in the normal in the land on the earth, okay, so equatorial lands or whatever the land, so on that they, so take an example of our Asia, okay, so continent. So in the Asia continent, the population of the human beings is more when compared to the north countries or north continents, because so because of this availability of the sun radiations, there is an warmer, the warmer in the atmospheric. So if the uh, atmosphere is warmer, okay, if it is colder, the activities are they won't get activities energy, and they will stop the activities. Okay, so if any activities must takes place means they need a energy. So that energy is from the sun, and those energy is in the atmosphere and they are trapped. Okay, that will warm the atmosphere, and they will helps to take or any activities will easily going on. Okay, so this is what the natural greenhouse effect. So in the figure, you just observe the solar radiation. This is what the scatter radiations or beam radiations, scatter radiations. They will fall onto the Earth atmosphere, and they will strikes the molecules, and again they will scatter, and they will again some of the portions will went back to the space, and some of the radiations will again striking to the another particles and back to the Earth atmosphere and reaches the Earth surfaces. And this atmosphere slowly absorbs that energy, and it is become warm. Okay, so warm, that warm energy, that is what the greenhouse effect. And this the temperature, you just take an example, the visible light absorbs the energy on the ground, and at the temperature of 20 degrees centigrade, for example, it emits the infrared light and at a wavelength, and this is of 10 micrometer. But CO2 in the atmosphere absorbs the light of that wavelength and back, okay, back radiate part of the earth. CO2 does not absorb incoming sunlight, which has shorter wavelength. Means CO2 absorbs only a longer wavelength. They won't absorb the shorter wavelength. Hence, the greenhouse effect brings about an accumulation of energy onto the ground. So in the ground, there is a more energy accumulation when compared to the top of the atmosphere. So let us take an example, a glass. Okay, glass easily transmits a shorter wavelength. A glass easily transmits the shorter wavelength radiation, which means that it poses a little interference to incoming solar radiations, but it is a very poor transmitter to the longer radiations. Glass won't transmit the longer wavelength, it only transmits the shorter wavelength. Shorter wavelength means it's a visible light. Once the sun energy is passes through the glass windows and it is become an absorbed by the some material, we place some materials, okay, it may be liquid, it may be solid, whatever it may be, gaseous, it will absorb, that media absorbs the energy, okay, and heat will into the and that heat will not re-radiate back into the outside, because that glass will transmit the sun rays or the shorter wavelength, and once it passes through the glass and the beneath the glass we placed some sort of substances, that substance will absorb and they won't re-radiate back, clear, re-radiate back into the outside. So glass therefore act as an heat trap. This glass we can used as a heat trap, means only one side, that shorter wavelength going into the glass, but it won't back from the glass, only one side movement. And this phenomena which has been recognized for some times in the construction of greenhouse, that is what I told, a synthetic greenhouse, and which can quite warmer and in the sunny days, even in the middle of the winter. This has become known the fact that the greenhouse effect. The solar collector for from the heating, as usually it is called a flat plate collector. For this, a best example is a flat plate collectors. Almost we have one or more a glass covers, although the various plastics and other transparent materials which often used to instead of that glass. Okay, and a black we can also coat the black paint, so that black paint will absorbs, we already know that the black color will absorbs the energy and white color 100% reflect back to the radiant or radiation. So we can use this black plate to absorb incoming solar sunlight, okay, and it is a fixed plate ordinary wind glass we can use for this ordinary wind glass. The black will absorb as an property of a black body, and ideal black bodies have not only the highest absorption but also they have highest emission coefficient for all the wavelength of the light. The emission increases with temperature. Of course, the emission will increases with the temperatures. And the re-emitted light is also a progressively shorter wavelength and greater energy. It has a temperature. So the shorter wavelength, it's always have the a greater energy or higher temperature. This we can use with some one expression, lambda max. Lambda max, that is what T, which is equal to constant of 2989 micrometer Kelvin. So T is the surface temperature, okay, of the black body, and lambda max is the wavelength at which the light emission reaches the maximum. So through this equation we can see how that the shorter wavelength will emit the energy. And come to the next interesting topic. So far we discussed what is meant by greenhouse effect. So greenhouse effect in simple word, it is an, okay, so it's a just like a glass building which is used to collect the heat. So in the glass building what happens, the glass is a transparent materials, it will allow a shorter wavelength, that is what light through that, and in the glass house we place some substances or we grow some plants so that it will absorb whatever the rays which are through the glass, and it won't back to the atmosphere or space. So this is what the greenhouse, artificial greenhouse. Natural greenhouse means the that transparent, instead of the transparent glass, there is an atmosphere. It is a transparent atmosphere, and the atmosphere having so many gases, particles, water vapors, or the liquid particles. So those particles in the atmosphere will absorb and traps the heat, and it will helps to warm the our planet. So this is what we call it as a greenhouse effect. So nowadays the greenhouse effect, so this is what the greenhouse from the sun. It is a positive type of greenhouse effect. It's a positive type of greenhouse effect from the sun. But nowadays the greenhouse effect is because of the excessive combustion of, we already know that excessive combustion of that wood, okay, coal, or any other petrol crude oil, and in industrial purpose, or else for the heat generation of, heat to electric, means in the power plants, okay. The and most commonly we can see in the automobiles, okay. So in the car, bike, there is an excessive combustion of petrol, diesel, leads to the greenhouse, okay. So it will emits the pollutants. That pollutants will absorbs the, that pollutant means there is a more in the carbon dioxide. If the more the carbon dioxide, what happens, it will increase the atmospheric temperature. Once the atmospheric temperature increases, it will slowly start melt the ice, north and south pole ice. Once the ice pole start melting, and it will increase the water level, and if water level increases, entire earth land will covered by a water. So that is the end of our human beings. So that is what the negative type of greenhouse effect, okay. So here we go with the, that is what positive means from the sunlight. That is what we discussed. So the ultimate theme of that greenhouse effect is just to trap the heat from the sun. Whatever the sun means, solar radiation, okay. So now first we will discuss very interesting type, one important type of solar collector, or a non-concentrating or flat plate solar collector. So this is a one important type, okay. So here non-concentrating, I told it's a non-concentrating. For this example is your water heater, which is placed on the terrace, okay. So most of houses, they are using this solar water heater. Solar water heater is the best example for flat plate type of collector or non-concentrating type of collector. So where the temperature below 90 degree are adequate, they are for the space and a service water heating flat plate collectors. This is what a one best type, which are the non-concentrating type, and they are particularly convenient. They are made in a regular panels of 1.7 to 2.9 square meters in the area, which is very small, okay, and are relatively simple to construct and simple to install. And the flat plate can be collect and absorbs both direct and diffuse solar radiations, and they are consequently, okay, and partially effective even in the cloudy days and when they are not in direct solar radiations. And this a flat plate solar collectors may have divided into so many types, okay. So in that many so in that there are two important types are the liquid heating collector, or typically liquid collectors, and solar air heaters are typically air heaters, okay. These are the two important types of flat plate collectors. We already know that this flat plate collectors means they are having one essential component. They are one essential component called observer and the collecting area. So collecting area and the observer, and these two will absorb both direct and beam, means direct or a diffuse radiations. And this is very effective in the very clear day, means clear sky, and also it is effective in the cloudy days, because in the cloudy days we won't get the direct radiations, but we get the a maximum of diffuse radiations. In the cloudy days we get maximum cloudy radiations, so that in the cloudy days also we can get the warm water. You just observe, in the cloudy days or in the rainy days also, you will get the warm water in your water heater, solar water heater. Is it correct? But in the clear sky, Okay, in the summer you will get a more effective, means very hot water you are going to get. That water temperature is very high. But in the cloudy days and in the rainy days, you will, of course, you will get a hot water, but the temperature is less when compared to the clear sky day. Okay, so because it is used for both direct as well as diffuse. It is used both direct as well as diffused type. Okay, and the first one is, I told, this a flat plate collector. So this flat plate collector, or a liquid type flat plate collector, having an five important components. It have five important components. So, of course, this liquid flat plate collector, which is used to for liquid heating collectors, it is also called as a liquiding heating collectors, are used for heating a water. There is a main purpose, heating a water, and non-freezing aqueous solutions. Here we are using non-aqueous solutions, and occasionally for non-aqueous heating transfer the fluids. Okay, air or gas heated the collectors are called solar air heaters. That is a second type. If it is used liquid, it's a liquid type of flat plate collector. Instead of liquid, if you use any gas or air, then it is called as a solar air heater. The principal difference between these two type design is a passage for heat for the transfer of fluid. That is a major difference. And come to the main components of this flat plate collectors are, the first thing is transparent cover. In the figure you can able to see, in this figure you can able to see, this is a transparent cover, first thing. Okay, second is a tube, that is for the tube fin. This is a transparent cover, and here there is a tube fin and absorber plate and insulation and the casing. This is what the casing, okay, and cover, and this is a housing or casing, we can call it as a, and this is called as an insulation, okay, and observer plates. This is an observer plates, okay, and heat transfer media, and which is surrounded by a tubes. Okay, tubes of fins we are using. So these are the important components in the flat plate collectors. The transparent cover, first one is transparent cover, which may be a one or more sheets of a glass or radiation which transmit the radiation, plastic or filament sheet. It may be a plastic or filament sheet, and which is a very transparent one. It will transmit the radiation or rays or shorter wavelength. Next is tube, which is placed beneath the transparent cover. Okay, so take an example, your water heater, house water, solar water heater. Okay, so in that there is a cover, transparent cover, and beneath the transparent cover there is a tubes or a fin or a passage or a channels are integrated with the collectors and absorber plate or to connected it, and they are carry the water or air. They will carry the water or air. And the observer plate, next is observer plate, normally metallic one. These are the observer plate, either it is a metallic one or with a black surface, either with a metallic one or a black surface. You can see this is what the observer, okay, it is always in the black color, okay, or a black surface, although a wide variety and maybe other materials can be also used. And the next, beneath these two there is an insulation or insulators. This insulation or insulators are used to avoid the heat loss, which should be provided with a back and side of the this devices, and and it will minimize the heat loss. And standard insulating materials may be the fiberglass or styrofoam, or maybe any other type we can use just to avoid the heat loss. Okay, so insulation will use the efficiency of the device. And the last one, entire thing is covered with a casing or housing. We can call it as a casing or housing. It's a container which enclosed all the components and protects from the weather or any other damage. So these are the important components of this flat plate collector. It may be liquid or it may be air type of flat plate collector. Yes, next is we will discuss one by one. That is what liquid heating flat plate collector. The second one is an we know that hair solar hair heater. The first one is liquid heating a flat plate collector. So this one, okay. So in the figure, you just observe. So it is a plate and a tube type of collector. It's commonly called as a plate or tube type collector. So in the diagram, you just observe it's a flat plate collector, liquid type of flat plate collector. It consists of, we already know that, the casing either made up of wood or a plastic having an area about 2 meter, 1 meter and 15 centimeter. It's a typical dimension. You can increase or decrease. Okay. In the casing, uh, the insulator is provided at the bottom. The insulators are provided in the bottom here. This is a casing. Okay. This is what a casing, and this is a insulator they are providing. The insulators is the provider in the bottom, and to check the conductivity of heat transfer, and so the glass wool fiber or asbestos or thermocoals we can use it as a this insulators as a insulators just to avoid the heat loss. And the above the insulator, the observer plate, we can just observe there is an observer plate above the insulator. There is an observer plate is fixed. The observer plate is made up of a good conducting materials like aluminum or copper. This observing plate, okay, it is made by a metal. Either it is made by the aluminum, okay, or it is made by the copper, okay. Just a good conductor. That material should be a good conductor of heat. We cannot use ceramics because ceramics are a bad conductor of heat. Okay, here we are using metals, that too particularly either aluminum or a copper, because they are conducting more heat when compared to the other metals. And it is coated a black. Of course it will coated black because a black is it will absorbs complete radiations just to increase the absorption capacity. Just to increase the absorption capacity, so the metal is coated by the black paint. As usually the black coating is done with a chemical treatment. Of course, for a more effectiveness, we are going with a chemical treatment. The selective coatings which allows to the maximum absorptions or radiations and minimum amount of emissions are applied on the observer plate. So the underside of the plate, it consists of an observer tube which run along the length of the plate. There is an observer tube. So these are the observer tubes. Okay, they are, so they are running along the plate. Okay, and these plates are also made by the some materials that are absorbs plate, and sometimes these plate itself bend to form the tubes. Okay, either these tubes are bent or they are straight. Though these tubes heat absorbing media, means they will consist of an water as a media and they are circulating. This media will absorb the heat from the plate and tubes and traps and that increase the temperature. It will absorb the heat and trap the heat and increase the temperature. And the media will absorb the heat from the plate and then tube, and its uh, temperature increases. Thus the way of solar energy is collected. And the above observer plate glass is covered, and just to provide or passing through the solar rays along that glass tube. And this glass covers helps to bring the greenhouse effect. Greenhouse effect means increasing the temperature of surrounding. It is called greenhouse. Thus increase the efficiency of the collector. And the more than the cover it is used, and it prevents a losses of radiations because of reflection. Okay, so this is what the typical working of a liquid flat plate collector means. Here there is a casing, which above the casing there is an insulation. Insulation avoid the energy loss, and there is a metal plates. It will good conductor, and it is coated by a black color, so that increase the absorbability. And along the this material there is a tubes. Okay, along the tube there is a media which is circulating, and that media will absorbs the heat, and entire thing is covered by a glass. It is a transparent cover which allows the shorter wavelength, and inside that there is, it will trap the heat and it won't reflect back, and it will causes the greenhouse effect. So this is what the typical working of a liquid type flat plate collector. Okay, so next class we'll discuss solar heater, air heater.